Mathematics is one of the interesting subjects that we study. In this video, we are going to cover Class 6 NCERT syllabus, Chapter 1, Knowing Our Numbers. The first topic that we are going to look at is comparing the numbers. I've randomly picked up an example from the textbook, which is basically asking which of these numbers is the greatest. It is quite easy to find out the biggest or the smallest number when the digits in a number is limited or it is less. But as it grows bigger, how do we go about deciding it? Right now we are dealing with 4-digit numbers in this particular case. And how should we determine if a number is big or small? It is pretty straightforward. A lot of us will be able to do it intuitively. But what is the mathematical reasoning and how do you approach it is something that we are going to discuss in this particular video. So the first step to check is basically count the number of digits in a number. The example that we have, all 4 of them have 4 digits. So there is no leeway there. We'll have to evaluate all the 4. The second point that we look at is the numbers which are at different place values. So, and how do we look at the place value? We read a number from right to left. We start with ones, then tens, then hundreds, then thousand, then 10,000, and so on and so forth. After 10,000 it will be lakh, then 10 lakh, and so on and so forth. So throughout this particular video and throughout the course, we'll call any number, we'll call the position of ones as O, tens as T, hundreds as H, thousand as capital T and small h, 10,000 will be double T and small h, lakh will be L, 10 lakh will be TL, right? So this is how we'll read, and so on and so forth. We'll just keep on following this particular pattern. Because all the numbers in the example are 4-digit, let us look at the thousand place, which is a 4th number. Your first number will be at ones place, then tens, then hundreds, and then thousands, right? So your 2 is ones at ones place, 5 is at tens place, 3 is at hundreds place, and 4 is at thousands place, right? So let us look at all the 1000 place numbers, and we say how many thousands are there in each of the example. And as we can clearly see, all of them are starting with 4. So clearly all of them have 4 thousands. So all of them have 4,000. So it is very clear that all of them have equal number of thousands. Now let us go to the next, because we are not able to make a decision out of the information which is available. So we'll start looking at hundreds, and when we do that, we see that the first number towards right has 3 hundreds. The second number also has 3 hundreds. The third number from right or second from left has 8 hundreds, and the fourth number or the first number from left has 5 hundreds. So clearly the biggest number will be the one which has higher number of hundreds compared to anybody else, right? Because everybody has equal number of thousands. So the biggest number is 4892, which is the second option from left or third option from right. Let us quickly look at the smallest number as well. How do we go about determining which of these are smallest? Same, we'll go with a similar approach. All of them have equal number of thousands. We'll start evaluating the numbers which are present at hundreds place in the examples that have been given, and the one which is smallest 100 will be picked up, right? So what we see, thus first and second option from right, which is this and this, are the ones which are having lowest number of hundreds, that is 3, right? Otherwise the rest two have, one is 800 and second is 500. So both of them are bigger than these two for sure. Now because the last two numbers again have equal number of hundreds, we are not able to take a call as to which one is the smallest, right? So we go to tens now, which is the second digit, right? And we see which is lowest number of tens. So the first example from right has 5 tens And the second example from right has 7 tens, clearly indicating the one which has lower number of tens is basically the smaller one. So the smallest number is 4352. Pretty simple. Let's go to next topic. So the second topic that we are going to cover is how many numbers can you make. So it is pretty straightforward. You'll be given a set of numbers and you'll be asked to create different numbers. You will basically be arranging and rearranging these numbers in different manner to get different values, right? That's pretty straightforward. But again, the question will be not that simple. Rather, you will be asked to create biggest possible number out of the digits which are given to you, or smallest possible number. And how do you go about doing that? Very simple. We'll be using a concept that we learned in the first topic, and we'll be implementing it here. We'll try to have maximum number of thousands, because this is a 4-digit number. So ones, tens, 100 and 1000. 1000 is a fourth place, and we have just 4 numbers and we cannot repeat them. So we'll have to create a combination out of it, and to get the biggest number we'll have to get maximum number of thousands. Then whatever numbers are left, we'll have to use the biggest one to get maximum number of hundreds, then maximum number of tens, and then maximum number of ones, or whatever left over will go to ones. And similarly, if a question is to create the smallest number out of this, then we'll try to get smallest number of thousand possible, the smallest number of hundreds, the smallest number of tens, and then smallest number of ones. So that's how we approach it. Let's solve this particular case. We have 4 digits, 2, 8, 7, 4. Let us arrange them in an order so that we have biggest number first and the smallest number last, and we call it what? We call it descending order, right? You descend from biggest to smallest, right? So you can simply go and put, by arranging these digits in descending order, you have already created the biggest possible number, which can come out of the digits which are provided. Similarly, if you again rearrange this number in ascending order, which is increasing order, the first number is smallest one and then it goes on increasing, you basically create the smallest possible number out of the digits which are provided. So if you have to create the biggest number, it will be 8, 7, 4, 2, and the smallest number will be 2, 4, 7 and 8. So that's your answer, right? It is pretty straightforward. Just remember descending and ascending. Descending is what? Greatest to smallest, and ascending is what? Smallest to greatest. Just remember these two concepts, and if you arrange all the digits in this manner, you get what? You get smallest number when you arrange all the digits in ascending order, and when you arrange all the digits in descending order, you get greatest number, right? Pretty straightforward, very simple concept to apply. Let us move on to the next topic now. Let us look at 10,000s. So this is one important topic which has been mentioned in the book, and it is very important to understand it. Why is it mentioned separately, right? So it is not necessarily 10,000 only. It can be applied to 10, 100, 1000, 10,000, so on and so forth. So here, I'll just ask a question. What is the biggest 2-digit number? Right? So if you apply the concept of ones and tens, so for 2 digits, let us create 2 places, and we know from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, arranging them in what? Ascending order, right? We know the biggest number is what? 9 is the biggest number, right? So our biggest 2-digit number will be 9 and 9. Can you think of a 2-digit number which is bigger than 99? Think about it. No, you'll not have anything. As soon as you increase it even by 1, it becomes a 3 digit. So 99 plus 1 is equal to 100, and this is what we are going to talk about in this particular topic. So using this concept, what we have learned, the biggest n digit number plus 1 is equal to smallest n plus 1 digit number, right? So if somebody will ask you, okay, what is the biggest 3 digit number? Very simple. Just go and put 9, 9 and 9. It is the biggest 3 digit number. But if somebody is asking you what is the smallest 4 digit number, simple. You go to biggest 3 digit number, do a plus 1, and it will give you smallest 4 digit number, which is 1000. How 4 digit? Ones, tens, 100 and 1000, right? You cannot have a 4 digit number which is smaller than this. So that's an important concept to understand, or you can remember it as well, that when somebody is asking what smallest x digit number, just try and put 1 and after it as many zeros, so that your count of total numbers or digits in that number is equal to x. So if somebody is asking you for smallest 5 digit number, so what you'll do, you'll write 1, then you'll put 4 zeros, total 1, 2, 3, 4 and 5. So this is smallest 5 digit number. Right? And similarly, if somebody is asking you for greatest 4 digit number, very simple, you will go and simply put 4 nines. You need not think about it. This will be always right. Just go on applying this particular logic. It is pretty straightforward. Let's move to the next topic. So this topic is about revisiting place value. I just spoke about place value, right? Ones, tens, 100, 1000, 10,000, lakh, 10 lakh, so on and so forth. The question that you will get regarding this particular topic will be to expand a number as per its place value. How do you go about that? The question that you will get on this topic is to expand a number according to place value, and let's try and solve a couple of examples to understand what does it means. Expansion of 78, how do you write it? So it has ones, tens, right? 7 is at tens place, 8 is at ones place. How do we go about writing it? We write it as 70 plus 8, or we can write it 70 into 10 plus 8 into 1, right? 8 is at ones place, so you multiply it by 1, and 7, it is tens place, so you multiply it by 7. Similarly, if a bigger number is given to you, let us say you're given a number 4528, how do you go about it? Very simple. You start from right, just so that you don't get confused. Say write the first digit on the right, which is 8, multiplied by 1, then write plus, then take up the second digit. So first is ones, second is tens, right? So you basically write what? You basically write 2 into 10 plus, you then take the 100, which is basically 5 into 100, and then you take the 1000, again a plus, 4 into 1000, and this is the expansion of the number that we are looking at, right? So it basically breaks up a number as per its place value, and sum total of all this expression that we have written will end up with a value which is 4528. So that's pretty straightforward and simple, right? It can also be done by making a table. We'll go through it in some time. There's also a concept of large numbers, just so that bigger numbers can be expressed with smaller writings, right? That's a concept that we all basically have to understand and know. For example, if you have to write 10, you'll write this. If you have to write 1000, you write 1, and after it you write 3 zeros. If you have to write a lakh, you basically write 1 and then you write 5 zeros, and so on and so forth. It goes on increasing. How do you simplify this, right? So something which is like this is called 10. This is writing bigger number. Something like this which has 3 zeros after 1 is called 1000. Something which is 5 zeros after 1 is called 1 lakh. Similarly, there are concepts of 1000 meter. We call it 1 kilometer, or 1000 grams. We call it 1 kilogram. So this is how bigger numbers are written. And then there is also a concept of place value, which I spoke about, that we'll go through a particular table. This is the table. Sometime back we just discussed place value and how to express a number in a place value format. And this is an example. You can create this kind of a table to basically break up a number in terms of its place value. Right now, when we are solving the place value problem, when we are trying to expand a number, we are writing multiplied by 10 and multiplied by 1000. What we have done here in this particular table is basically we have created different columns in this particular table which represents that particular 1000, lakh, 10,000 or whatever, right? So if I have to take an example which is like let us say I have to find a place value for 7342, right? How do I go about it? I know the first digit will come here under the ones place, the second digit will come here on the tens place, third digit will come under hundreds place, and fourth digit will come under sevens place, and then you write it in terms of expression, which is 7342, right? This is how this table is created. It is pretty straightforward. All the places place values that we spoke about and saw, we don't write 7 into 1000 anymore. We have basically created a column for 1000 here, and in which we just put the value 7, and it is much simpler way of doing it, though you'll have to make the table, but the chances of making a mistake is much lesser when you approach that particular problem like this. So highly recommended you do it. You score all the numbers in the written exams. Not recommended for competition though. The next topic that we are going to look at is commas. How do we use commas and why do we use comma is something that we need to understand. When there are a lot of numbers written, it becomes really difficult for somebody to count ones, tens, thousands, and so on and so forth to understand if it is a lakh, 10 lakh, 20 lakh, and whatever. So standard practices have been developed as to how do we denote 1000 or a lakh by placing commas so that it is easier for somebody to read. In our Indian system of numeration, we use ones, tens, 100, 1000, and 10 lakhs and crore. Commas are used to mark 1000, lakhs, and crores, right? So if I write 1000, I'll write 1 and then 3 zeros, and I'll put a comma here, right? We also use it to mark lakhs and crores as well. So how do we go about it? Let us say there is a random number 58932673, right? So I'll first mark the 1000, which is here after 3 digits, ones, tens, and 100, and between 100 O, T, H and TH, right? Between 100 and 1000, I'll place first comma, then I have to mark lakh. So after 1000 there will be 10,000 and then lakh, right? So between 10,000 and lakh I have to place next comma to signify it has a value which is worth a lakh, and then I have to, after lakh, then there will be 10 lakh and then crore, right? So between 10 lakh and crore I have to basically mark the third comma. So the numbers or the digits that we basically put a comma between is basically to signify thousands, lakhs and crore. If you have to remember, just remember it, that in Indian system of numeration we use comma to denote 1,000, a lakh and a crore. And this is done for ease of reading and ease of understanding. So if somebody writes a number like this, right, and put a comma here, here and here, just by looking at number of commas you will be able to say, okay, there are 3 commas, it means the number is in crore, right? So that's how it makes for a very easy reading whenever commas are used in writing a number. The next topic that we are going to cover is estimations. Let's go to that. So estimation and rounding off are basic techniques which are used in day-to-day life to simplify our calculations, or whenever we are dealing in big numbers and we do not have a calculator handy, or we do not want to spell out the exact number values somewhere, then we basically do an approximation and estimation to arrive at a decision. Let us say there's a number line 258, starts at 258, then 259, then 260, then 261, then 262, 263, so on and so forth. And let us say if you have a number which is, let us say 263, so the estimation will be basically, you'll go to the nearest 10, which is 260, and you'll basically say that okay, it is somewhere near about 260. That's the conversational language that we normally use, right? And people use different degree of rounding off for different scenarios. Rounding off can be done at tens place, ones place, tens place. It can be done at hundreds place. It can be done at thousands place as well, depending upon the magnitude that we are talking about. So in this example, we are rounding up to nearest ones place. That was from 3 ones. We basically went to zeros, right? So similarly, if somebody will ask you to round, let us say 4, 3, 5, 9 to nearest tens, you basically will go and write it as 4360, that you have rounded off this particular number, right, which is the tens place. If the same number has to be rounded, for this is rounded to tens, if somebody will ask you to round it to 100, then what would you write? You'll basically write 4300 or 4400. Which one will be correct? Tell me. 4300 will be wrong, 4400 will be right. Why? Because 359 on a number table, 359 is closer to 4400 than 4300. It is closer, right? It is the difference between 4400 and 4359 is just 41 compared to 59 here, right? So it is closer to 4400. So when you have rounded it off to 100 place, which is the third digit in the number, you'll basically round it off to next 100. So that's how rounding off happens, and that's how estimation is done. By the way, if you are liking the video and enjoying learning through this, do consider liking the video as well as subscribing to my channel. That will be awesome. Moving on to the next topic now. Using brackets. So in the first part, we are going to learn about solving the bracket, and second part, expansion of bracket. So solving the bracket is really simple and straightforward. We already know addition, subtraction, multiplication and division. It is just prioritizing the portion of the equation where we need to focus and do that first before doing it anywhere else, right? So I'll just take an example for the first case, which is solving the bracket. Let us take a case of 2 plus 3 multiplied by 4 plus 5. Now if you have to solve this particular problem, we can go about it in multiple ways, right? One way of doing it is basically adding 2 plus 3 and 4 plus 5 and then multiplying both of them. One way of doing it will be to basically multiply 3 plus 3 and 4 first and then adding it to 2 plus 5, and we'll get different results. If we add 2 plus 3 and 4 plus 5 and then multiply them, we'll basically have 5 multiplied by 9, which is equal to 45. That's first approach, right? Second approach is basically when we go ahead and multiply 3 and 4 first and then add them together. So 2 plus 3 into 4 will be 12 plus 5, which will be equal to 19. So we clearly see there are two different results. Now to address this particular complication, we had a rule called BODMAS, right? BODMAS is brackets of division, multiplication, addition and subtraction. This is the sequence in which you solve anything. So according to the BODMAS rule, if I have to solve the above equation, I will be first solving it for multiplication because it has higher priority, then addition and then subtraction. So the second solution that we did here is what is the right way of doing it. This is basically right and this one is wrong, because in order of priority we will first solve it for multiplication and then we will solve it for addition, right, according to the BODMAS rule. Now that it is clear, what if you want to change that sequence and you want to prioritize addition first, like we did in first case, and then do multiplication? How would you go about doing that? You can achieve that by use of brackets. Why? Because in BODMAS, brackets comes as the first priority and then division, then multiplication, then addition and then subtraction, right? So how would you go about doing that? If I have to make sure that we solve the equation which is given here in the first manner, we'll have to use bracket. How? So I will basically go and I will basically write the same equation multiplied by 3 multiplied by 4 plus 5, 2 plus 3 multiplied by 4 plus 5. And what do I want? I want the addition to happen first and multiplication to happen later. I will be able to do it like this. I'll place a bracket, and that ways we will have to solve for bracket first and then we'll have to multiply. So I'll first solve for bracket and remove the bracket, that is 2 plus 3 will be 5 multiplied by 4 plus 5 is 9, and hence the result is 45. So you understand how bracket is used. Now what we are looking at, we are trying to look at solving of brackets, right? So if I have a particular case in which 1 plus 2 multiplied by 3 divided by 1 or divided by 2, if I have this particular case, by order of BODMAS, I should be first dividing and then I should be multiplying and then I should be adding, right? But I want to reverse that order. I'll basically put, if somebody puts a bracket like this, then in that case I'll have to first prioritize this and then I'll have to go with division and then multiplication, right? So it will be basically 1 plus 2 is equal to 3 multiplied by 3 divided by 2, which is equal to 3 multiplied by 1.5, which is equal to 4.5. So that's our result, right? So that's about solving of brackets, right? If an equation is written like that, you will first solve the things which are written inside the bracket. The second portion of this is expanding of brackets, right? So if in case I have somebody writes it like this, 5 into 1 or 5 bracket 1 plus 2, how do you go on expanding this? It is very simple. Bracket technically means multiplication. So if I write 5 into 1 plus 2, it basically means 5 has to be multiplied by this as well as this digit, both the values. So an expansion of this particular expression will be 5 into 1, the first portion, plus the plus stays as is 2 multiplied by 5, right? So you go on adding that particular number. Let's take one more example. Let us take 3 multiplied by 2, alright, and divided, and outside the bracket there's a 5. It clearly means what?
5 multiplied by 3, and the multiplication sign stays as is, and 5 multiplied by 2. So 5 gets multiplied by first digit, 5 first gets multiplied by first digit and the second digit. Simple. And you basically apply the same rule each and every time, and this is how we expand the brackets. So Roman numerals are basically used for different text editing, and basically while you're writing a point or something, to list down point, because writing large number through Roman numerals is pretty complex and it is very time taking. On top of it, applying different operators like multiplication, addition, subtraction, etc. is quite difficult. It is not very intuitive, and you'll have to remember a lot of things. So that's why Roman numerals has been restricted just to literature. Most of the times you basically list down your points in form of different Roman numerals, and we'll just quickly walk through that. So I'll quickly list down the Roman numerals that you'll be using very frequently. It is generally used till a number of 10 or 20 in the write-ups that we write normally, and I'll just list it down for all of you to remember. 1 is represented as an I, capital I, that we write. 2 is represented as 2 bars between the I. 3 is represented as 3 bars between the I, and 4 is represented as I and V. So pretty straightforward till now, right? Till 3 it is pretty simple. For 4 it is I before the V, 5 is equal to V, 6 is equal to an I after the V, 7 is equal to 2 I's after V. Basically you are saying that V is 5 and after 5 you are adding 2. So this is how it is represented, V and double I, right? Similarly 8 is represented as V and 3 I's. So you have to remember 5 is represented by V, 1 less than 5 is 4, so you basically write an I before V, and 6 is basically greater than 5 by 1, so you write an I after V. 7 is 2 unit greater than 5, so you write 2 I's after V, and so on and so forth. And similarly for 8. Now 9, again it gets interesting. You basically do not represent 9 as a 9 number, you basically represent 9 as a number which is 1 less than 10, and 10 is represented by X, and you basically put the I before X, right? 10 is represented with X like you said, and so on and so forth. We will keep doing it, and let us say if you have to get 11, 11 is X and I, 1 I, 12 is X and double I's, 13 is X and triple I's, 14 again we go back, we basically will add the 4 which is here and we'll add the 10 which is here. So 10 plus 4 is 14, so we'll represent it as X, I, V, 15 will be X and V, and so on and so forth. We'll just go on doing that. 20 will be what? 20 will be 2x's. It is double of 10, right? So it is basically X and X. Similarly 30 is what? 30 will be 3x's. Now again, one more thing that we have to remember for understanding how 40 is represented is, we have to understand how 50 is represented. 50 is represented by an L, right? And what is 40? 40 is 10 less than L. So we'll place an X before L, like we are placing an I before 5 to represent 4, similarly. Or to represent 9, we are placing an I before X. Similarly, for representing 40, we will basically be placing a 10 before 50, that is X before L. So 50 is L, right? Similarly 60 will be what? 60 will be what? Similarly 60 will be L and an X, which is basically 50 plus 10. 70 will be L double X. 80 will be what? 80 will be L triple X. What will be 90 again? For 90 we will have to understand how 100 is represented. 100 is represented as C, so 90 will be represented as 10 less than 100, which is XC. right? Like you have to remember this. There's no easy way of knowing it. The number system that we use is pretty intuitive, and we have grown with it. We are easily able to understand. So the key point that I would recommend that you remember for this particular portion, Roman numerals, is that 5 is represented as V, 10 is represented as X, 50 is represented by L, and 100 is represented by C. If you remember these 4 points, you will more or less get it right. And before I close this, I would also like to cover a couple of more numbers, like 500 is represented by D and 1000 is represented by an M, right? So if you remember these, you'll get it right most of the times. So this is the end of the video and the chapter as well. Let's catch up in the next one, which will be about whole numbers. Enjoy learning. Bye.